Hello everybody, welcome to this video about transformations to the quadratic parent function. If we're going to talk about the transformations to quadratics, then we need to talk about the parent function first. So go ahead and fill out this table for the parent function. We're going to do -2 into the equation for x squared. -2 times -2 is a 4, -1 times -1 is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Okay, that table was pretty easy, and hopefully at this point you're used to drawing the parent graph. 0, 0, 1, 1, and 2 goes with 4. Then, because of the way the axis of symmetry works, we can just mirror this over. Since this point is one space to the right, if we go one space to the left of the vertex, then we should be at the same height as what we see on the right side. That's what the axis of symmetry does. If we go two spaces to the right of the vertex, we should have the same height, the same y, as we would if we went two spaces to the left. Okay, so the vertex, pretty easy. It's at 0, 0. Y-intercept, where is it touching the y-axis? 0, 0. X-intercept, where is it touching? It's only touching at one time for this graph. It's touching at 0, 0. And here's where we're going to do some transformations. A transformation just means a change. So we're going to change the parent graph. So just go ahead and copy it over again. You should have memorized the points by now. -2, 4. If you didn't memorize them, just look back up here and graph them down here. Okay, so that's the parent. We are now going to graph the other one, and I'm going to go ahead and use my graphing calculator app. Push y equals, clear it out, -4x squared, and just open up the table. Once you're used to this, after this lesson, you'll see why I didn't really need to use my graphing calculator to do that, but it's fine. So we have 0, 0 as our first point. Our left point is at -1, -4. The point one space to the right will be at +1, -4, and that's all that's going to fit on this graph. Now let's talk about some of the differences. Well, one's upside down, one's right side up. Besides just the direction they're pointing, if we look at what happened whenever we plugged in the number 1, when we plugged in 1 here, it gave us 1. When we plugged in 1 in the other one, it gave us -4. According to that transformation, this new graph is going to be 4 times skinnier than the original graph. Because this is a 4 that's multiplying the x squareds, we call this a vertical stretch. Okay, let's try the next one. We need x squared. I'll go ahead and put that in purple again. And we're going to do x squared plus 3. I'll pull out my calculator. If you see how fast I do the calculator, that's how fast you should be on your own computer doing this. But the only way you're going to get to that speed of knowing what to do and what buttons to push is by practicing. So don't only watch the video, make sure you're practicing with your calculator too. 0 goes with 3, -1 goes with 4, +1 also goes with 4, 2 goes with 7. So I'm just going to be looking over here as I write which numbers on the left, okay? If we look at these two graphs compared to the first two graphs, you can see that there isn't going to be a difference that one's upside down, one's right side up, but there is a difference, and it's that the y-intercept is higher. It's shifted up by 3. And you can count that with the boxes. 1, 2, 3. And then if you look at the next spot over, this one was 1, 1. Now it's 1, 4. That's 1, 2, 3. Every y moved up 3. I want you to do these two right here. I'm going to show you the answers in a bit, so pause the video, try them out. Check your first one first, and then keep on working on the second one. The reason I want you to do both of those things, even though it's the same answer, is because sometimes they're going to ask you for the minimum or the maximum in a word problem. Sometimes they'll just ask you for the vertex, and then you should already know what the vertex is. If they ask you the minimum or maximum, just practicing, knowing that that's the same thing as the vertex, is good practice to have. Let's check this second one. When comparing the red graph to the purple graph, notice that they aren't touching, and they never will touch. But even though these curves are not going to touch, they aren't parallel either. Whenever we were learning about lines, the only time two lines didn't touch was if they were parallel. With quadratics, though, they don't have to be parallel. They can have different slopes, but as long as they have the same width, if one of them is shifted up or one of them shifted down, they're never going to intersect. Now let's talk about why that is. Whenever we have parameter changes to the variable a, whatever's going to multiply the x squared, you already know that that's going to change whether it opens upwards or downwards. But besides just changing whether it opens up or down, that's the original. Whatever multiplies a is also going to affect how skinny or wide the graph is. And while I do want to write the word skinnier, the correct math word would be narrower. Let me just go ahead and make a little number line that describes what's going to happen when. Whenever your a is less than 1, but it's still greater than 0, this is going to make a wider graph. When we're saying wider, we mean this is going to make a graph that's wider than the parent. Whenever we have a and it's greater than 1, a is on the greater side than 1, and any number higher than that, then this is going to be a narrower than the parent. If it's right in the middle, a is equal to 1, this will be the same shape as the parent. I want you to go ahead and explore the changes in a for these 4 questions, but notice that they're not just doing the parent function. In these examples, they're showing that you don't even have to use the parent function. You could start with something else. You're going to graph this first. Then you're going to do this new one. This is going to make a second graph on the same thing. So over here, there should be 2 graphs for each of these questions. And I am okay if you use the graphing calculator for this to do it faster. You do an x squared plus 4. Open up the table. Then you can clear that out. And then in this first example, whenever it says a is doubled, that's going to mean that y will be equal to 2x squared plus 4, Whenever you double a, that doesn't change the entire equation. It's only changing the number that's multiplying x squared. All right? So be careful. If it says a is halved, then you're only going to change that number right there. If it says that a is quartered, then you're only going to change this and you're going to divide it by 4. Okay, go ahead and try those out.